So we talked about this on Friday, but we're going to go over it again here very carefully. The whole purpose of today is, one, reviewing two of the factoring types that we haven't done in a little while. We did difference of squares just previously, but we haven't done simple trinomial and common factoring in a little while. So reviewing that and making sure we know how to do those two. But also, if you're given some expression and you're not told what type of factoring, to be able to determine and recognize what type of factoring. The skill of being able to analyze an expression and look for the patterns and look for what it's like is a really important mathematical skill. It's a hard skill. It takes some practice to get there, but it's really, really valuable in terms of answering all different kinds of questions. So let's go ahead and get started. So before we talk about those properties, let's just take a look. So here's 6 different examples. How could I determine what type of factoring I would use on each of these 6? For each of the 6, there's a right answer and there's 2 wrong answers. If you try to do common factoring and there is no common factor, it's not going to work. If you're trying to do difference of squares, but it's not a difference of squares, it's not going to work. So the first step is to figure out what kind of thing you have. One of the things that's going to be a big help to us is the number of terms. Okay, so you'll notice that a difference of squares has 2 terms, whereas a trinomial has 3. By definition, a trinomial, tri means 3, triangle, tricycle, right? Always refers to 3. So a trinomial has 3 terms. So when you have 3 terms and it's in this special form where I have just x squared plus a number x plus a number, that's a simple trinomial. And that means we're looking for, if you remember, 2 numbers that add to this and multiply to that. So we'll see an example of that in a moment, but that's how that one works. Again, you can go back and refer to one of the older videos to see more examples of how that works. Simple trinomial. 2 numbers that add to the middle term and multiply to the last term. So if I've got 3 terms and it's in this form, then we're doing simple trinomial factoring. If I have 2 terms, then what I'm looking for, do they have perfect squares? So we saw the list of perfect squares before. Here it is. There's our list. It continues. It goes on. There are bigger ones, but those are the ones that we like to recognize. So is it a perfect square that we're looking at? And is there a subtraction sign? And if there is, then it's a difference of squares. Remember, if it's adding, that's not a difference of squares. That's a sum of squares. You're adding squares. You're not subtracting them. So that's different. It won't work. But if you're subtracting 2 terms, both squares, then it's a difference of squares. The last possibility is that it's a common factor. Now, the tricky thing is a common factor can be any number of terms. It can be 2, 3, or even more. So what you're looking for is that maybe it's not a difference of squares, but it has 2 terms. Okay, if there's no minus sign, then it could very well be a common factor. Or if it's 3 terms, but it's not in this exact form, and we will see an example of what that means, then it could be a common factor, or it is likely a common factor. Or in general, it's a common factor if there is some kind of GCF, if there is something you can divide out of 2. So good examples to look for is all the coefficients are multiples of 2 or multiples of 3, or there's the same variable in every term, then it's common factoring. Okay, so again, it's important to read back over this after you start practicing. Remember, you're looking for number of terms, but you're also looking for things like what are the coefficients and what does the expression look like. Let's take a look at the first one. So what do you think? Is it a difference of squares? No, because a difference of squares has to have 2 terms. Is it common factoring? There is no common factor in those 3 terms. 1, 2, 3. There's nothing in common that I can factor out of those 3, but it is a trinomial because there's 3 terms, and there are 2 numbers, and it has this special form where it's x squared, and then a number x and a number. Okay, so I can look for 2 numbers that add to -8 and multiply to 15, and you can pause the video and try to figure them out if you want. But they are -5 and -3. Quick reminder, 2 negatives multiply to a positive, right? You have to look at the signs to understand what the signs of these numbers are going to be. That's a big part of trinomial factoring. So they multiply to a positive, but they add to a negative. That means they're both going to be negative, and it means they're going to add up to 8. They're going to add up to this number, not subtract to that number. So 5 plus 3 is 8, and they're negatives. We often think about the numbers first and worry about the signs after, but it is all part of the process. We have to do some of it, at least some of that thinking along the way. Okay, let's take a look at B. B and C, you look how they both have two terms, but really compare and contrast them. Say what's the same, they have two terms. What's different? B has a minus sign between them, and everything is perfect squares. C doesn't have that. So that's why these are very different questions, and I'm going to factor them in a very different way. 4 is a perfect square, 25 is a perfect square. So this is indeed a difference of squares. And the square root of 4 is 2, so it's 2x. Plus the square root of 5, 25 is 5, so 2x plus 5, and 2x minus 5. And then the last one, again, it's not a trinomial, it's not a difference of squares, so the only thing that's left is a common factor, and it's possible that you could see a question or an expression that's not factorable. Not going to give you too many of those, but it's certainly possible for that to happen. So you would have to still ask yourself, is there a common factor? But in this case, there is. And the common factor is 2 because I can divide both the numbers by 2. And they don't have a variable in each term, so there's no variable part to this. So 2x divided by 2 is just x, and 10 divided by 2 is 5. And remember, the whole point of this is when I re-expand, I get back that first step. So 2 times x is 2x, and 2 times 5 is 10. So you can always be checking your work as you go. Let's take a look at D. And if you were in class on Friday, you'll remember that we kind of talked about this. This is one that's trying to look like a difference of squares because everything's a perfect square. But when it doesn't have a minus sign between them, it's not possible. So it's not a difference of squares. It's close, but it's not. It's not a trinomial because it only has two terms. And there is no common factor. So the only thing that's left that's possible is a common factor, but there isn't one. So this one's not factorable or not possible. Okay, so that's one that just helps us think about all the three types of factoring and what they're like, what they need to be like. And I think when we see why this one's not possible, it really helps us understand the other types. And if we compare that to question E, well, then we can see that E is a little bit different. It's still not a difference of squares because it still has a plus instead of a minus, but it does have a common factor. So I can divide 4 out of both, and 4x squared divided by 4 is just x squared, and 16 divided by 4 is 4. So really looking at the difference between those two can help us understand a lot of this as well. And the last one, so it's not a difference of squares because it has 3 terms, and so difference of squares has to have 2 terms. So it looks like it might be a trinomial, but a trinomial has to look like this: x squared plus something x plus something, where those are numbers, and it would be 2 numbers that add to that and multiply to that. And this doesn't have that because it's got x cubed and it's got a 3 here, so this is not going to work for us. So instead, if you look carefully, you can see there's a common factor in each of those. Those are each multiples of 3, and there's also an x in each of those terms. And very briefly, when you're common factoring, you look at the exponents and you pick the smallest exponent. What's the exponent there? When we don't see one, it's a 1. So the smallest exponent is 1. So 3x is my GCF, my greatest common factor. 3 divided by 3 is 1. X cubed divided by x, I subtract the exponents. That gives me x squared. 6 divided by 3 is 2. X squared divided by x, again, I subtract the exponents. 2 minus 1 is 1, so it's just x. And 30 divided by 3 is 10. And x divided by x is gone. And so I'm done. Now, what's interesting here is that does look like a simple trinomial. It is x squared plus a number x plus a number. And it is certainly possible in grade 11. It's not impossible for that to come up in grade 10, but that's not something we're worrying about. But in grade 11, it's certainly possible that you'll factor once, and then what you're left with, you could factor again. So it's possible that what you're left with here, you could also go ahead and factor. But in our case, that's not possible, and that's not something you really need to worry about. There's no numbers that add to 2 and multiply to 10, so this one is all finished. Okay. So take a look at the worksheet. You can do some practice in the posted worksheet, but also the posted app that lets you check your work as you go and gives you a little bit of feedback as you're working. And then there'll be another video posted with some of the solutions in case you get stuck on any of this.